In this quick video, we're going to understand the basics of what's happening when the light turns on and off, as it did in the first video of this series. You will notice that I've gone ahead and I've deleted all the comments. That's just to make things a little cleaner for purposes of instruction. You can delete the comments if you wish. Just make sure that you don't accidentally delete any brackets, curly braces, or semicolons as you do that. Otherwise, you will get an error when you try to run the simulation. So first things first, going back to block coding, and this is just to always continually back to build on our prior knowledge. Going back to block coding, the void setup is similar to the start block, and the void loop is similar to the forever block. We know that the start block only ever ran once. It's very similar with setup. It's going to run right at the start. And void loop will continually run forever, top down. So as it gets to the last statement, it will return back up or loop to the start and then keep running the program again forever until you turn it off or tell it otherwise. So in the last video we talked about syntax. We had this idea of a function and arguments, and that is the primary purpose here for this video. We can see that void setup is an argumentless function. No arguments or variables are passed in, and within this we have a code block that has a single statement: pin mode LED built-in output. Now LED built-in is a keyword. It also means 13. So I'm going to go ahead and, for the purposes of this video, switch it to the value of 13, because we know by looking at the LED that it's plugged in to pin 13. And I'm sending a signal out, so I'm going to tell it to signal outwards or towards the LED using the command or keyword output. Notice how it's all in capitals. I'm then going to move on to my void loop, which is again an empty function, has no arguments, but you'll notice that the curly braces surround 4 statements. So whenever I run the loop, I'm going to run these 4 statements in sequence and then return back up to the top. So when the robot or the circuit turns on, void setup will run, then it'll enter the void loop, and then it'll run top to bottom over and over and over again. As it's doing that, it's going to run this function called digital write, which you can read about more below the video here in our lesson, and you'll see that it takes a function argument of LED built-in and high. Because I switched my pin mode to 13 up here, I'm going to switch it in here as well to 13 and 13. We'll get into variables in the next video. And high and low, we talked about in a video relating to the Arduino as a digital signal being on or off, 1 or 0, high or low. You can even think of it like a Boolean variable from previous lessons, true and false, when you're going forward with this. So what's going to happen here is as the loop runs, it's going to digitally write, so it's going to send out information on the write on a digital pin, referred to as pin 13, which is right here, and it's going to turn it on. It's then going to delay or wait 1 second. The value of delay is in milliseconds. There are 1,000 milliseconds in a second. So if I take 1,000 and divide by 1,000, I get 1 full second. It's then going to digitally write pin 13 low, which is effectively turning it off, and then it will wait a second. So if I go ahead and start my simulation, we should be able to see that the light bulb turns on for a second, off for a second, and it just alternates back and forth in relation to the code here. So if I stop my simulation and come back in here and change these values, let's say 2,000, so 2 seconds on and 5 seconds off, and I start my simulation, we'll see that the light bulb turns on a little longer, but stays off a lot longer, a whole 5 seconds before it lights up again. So I can stop my simulation and I can play around with those values. So let's go ahead and set them back to maybe 1,000. Do that. And let's look at what happens if I change the pin value. So let's change the pin value to 12 and 12 and hit start simulation. We'll notice that the light bulb doesn't turn on at all because we're declaring pin mode 13 as an output, and while we don't have pin mode 12 as an output, we are trying to write out on pin 12, and you can see that there's nothing connected here. So if I stop my simulation, I change the pin mode to 12, and I just move this wire. Let's see if I can grab it, there we go, and start my code again, we'll see that the light bulb now lights up. So we can begin to see that these keywords of high and low represent on and off, that the pin number 12 or 13 in the prior example refers to these physical holes, and that the keyword output sends a signal out to the LED. Finally, the delay function takes a single argument, and that is just of the time you want to wait. One thing to note before wrapping up this video is that when you use the delay statement, the Arduino actually pauses and doesn't do anything else. So if you're trying to have multiple functions work together to control your robot or circuit, you may want to look at a function called millis, which looks at the milliseconds passed rather than the delay statement.